Hi, it's Bruce again, and welcome to my Colorado Rocky Mountain lab. And today we're going to take a look at yet another Keithley 178 digital multimeter. It's a real beauty. Beautiful shape, real nice handle, bright display. It's been calibrated. We'll read anything from DC 2 volts full scale to 1000 volts full scale. The Keithley 178 is a 4.5 digit digital multimeter. So what that means is you can get 5 digits, as you are seeing right now on this display. So we're reading 1.9000 volts. And my recently calibrated Hewlett-Packard 3441A, which is a 6-digit unit, 6.5-digit unit, is also reading 1.9000 volts. So they're both in wonderful agreement. So we can read anything from 2 volts to 1000 volts. Let's see, we've got that's AC or DC. And we can read resistance from 2000 ohms full scale to 20 megohms. We're going to take this thing through its paces, but let's first just kind of take a good look around it. Okay. The underside here, we can see we have the operating instructions on the bottom. Nice rubber feet, good looking underneath, nice looking from the side. Top is beautiful, got a nice, I don't know, leatherette naugahyde kind of grain to it. Handle adapts itself to many positions. The original handle was broken, so this, of course, was a rebuilt handle, but it's a beautiful handle. And then in the back we have the line voltage and service manual and so on. And then we have a nice cord goes into it. So we're going to use the verification sheets that come with the manual to verify the voltages that we obtain on the ranges, and that they're within the calibration limits. So give me a minute, we'll get started. Okay, we are on the 2 volt range DC input. We are reading 1 and 5 zeros, 1.50 volts DC on the Hewlett-Packard 34401. And we are getting a reading of 1.0001. So 1.0001. Our readings are allowable and considered good if they're between 0.9995 to 1.0005. And we're 1.0001, so we're right in the middle. We are 100 microvolts high in reading, and that seems to be a characteristic of this meter. As I go up the range closer to 2 volts, like at 1.9, the two meters match exactly. 1.9 volts is the calibration point for the unit. But we are better than 0.04% here. We're going to go to the 20 volt range next. Still maintain the 1.000, which is good. And we want to go to 10 volts. And we have 10 volts, 10.40 on the Hewlett-Packard, and we are reading 10.00, and it's a 0 or a 1. So we're going to write down the 1, that's the worst case. 10.001. We are considered good if we're between 9.995 to 10.005. And of course at 10.001 we are a millivolt off of perfect, and we're right in the middle. So again, a 20 volts scale performance is excellent. We're within the 0.04%. In fact, we've settled more at the 0 than at the 1. So let's go to the 200 volts input. Change the range. 10.00. Maintain that, no problem. Let's go to 100 volts. We have 100.001, so we're a millivolt above 100 volts on the HP. And we have 100.00. So we're dead on the Keithley. 100.00. We're good if we're between 99.95 to 100.05, and still within the 0.04% that we're rated. Let's go to the 1000 volt scale. We have 100 volts, that's good. And we're going to take ourselves up to 1000 volts. 1000.01. Okay, 1000.01 on the HP. 1000.0 on the Keithley. So 1000.0, perfect. We're good if we read between 999.5 to 1000.5, and we were right on it. So we passed the DC performance check beautifully. Let's move on to AC. Okay, we're getting our AC voltage now from this Fluke 5200A. We're on the AC range, and we are reading right now 1.50 volts AC on the HP. And we see that we're reading all 9s on the Keithley. So let's 0.9999 with a 1 volt input. Basic accuracy for the AC ranges it's about 0.3% plus so many digits. We would be good if we read between 0.9945 volts to 1.0055 volts. We're right smack dab in the middle at 0.9999, 100 microvolts off of a perfect 1 volt. So beautiful there. Let's move to the 20 volt range. Okay. And I want to up the voltage here to 10 volts. Okay, we have 10 volts, 10.4 zeros. We're getting 9.999. Yeah, sometimes a flashing 8, but .999, and that would give us, or put us rather, in the middle again. We would be good if we read 9.955 to 10.045 volts, and we are reading 9.999, a millivolt off of perfect 10 volts. So again, perfect both ranges. Let's go to the 200 volt range. Okay. All right, we got 100.000 volts AC. And we're getting a reading of 100.08. So 100.08. We would be accurate if we were between 99.55 to 100.45, and we're 100.08. So again, right in the middle. We are 0.08 of a volt off of perfection, but beautiful. And if we go to the 1,000 volt range, the best I'm going to be able to do here is about 120 volts input. I don't have the amplifier to allow me to go to 1,000 in AC. But let's go ahead and give ourselves the maximum that I have. .00 volt AC on the Hewlett-Packard, and we have a reading of 119.7. So 119.7. Okay, following the same formula for the allowable readings, which on the 20, 200, and 1,000 volt scales is to subtract and for the low side subtract 0.3% of the reading desired, and then subtract 15 digits, which in the 1,000 volt range we have 1 decimal place, so it'd actually be 1.5 volts. So we would be accurate if for 120 volts on the 1,000 volt range using the allowable readings formula. We should be accurate between 118.14 volts to 121.86 volts, and we got 119.7. So well into the middle, and within 0.3 of a volt of being perfect at the 1,000 volt range. So we are within the allowable readings, and we passed the performance test using the 120 volts on the 1,000 volt range. Wish I could go to the 1,000 volts AC. I just don't have the equipment to do it, and that's the best we can do. We're going to move on to resistance now. Take a look at it. Okay, we've switched to resistance, and we are using this resistor 2, which is accurate to within 0.01% on its ranges. And we currently are on the 2,000 ohm range. We have a reading of 1,900 ohms coming into the unit, and we are getting a reading of 1.8994 to 5. We'll say 4, 1.8994. So 1.8994. We would be accurate on this unit as long as we read between 1.8989 to 1.9011 kiloohms. We are reading 1.8994, which puts us very close to the middle. We are, 600 millionths of an ohm off of a perfect 1.9K. So anyway, that's good. Let's move on to the 20K range. Okay, 20K, if we want to get 19,000 ohms on the 20K range, and we are reading between 18 and 3/9 to 19,000, probably getting more to the 19,000. I'm going to go ahead and claim perfection, so pardon me, but we've got 19.000 kiloohms. It's perfect. We'd be good if we were between 18.990 to 19.010. but 19.000 is better yet. Okay, let's move to the 200,000 ohms range. And we want 190,000. Okay, we've got 190,000 ohms on here now. And we're getting a reading of 189.99. 189.99. We'd be good if we were between 189.90 to 190.10. At 189.99, it's like reading 190. It's really right in the middle. We're good. Let's go to the 2 megohm range. And we got to dial in 1.9 megohms. Okay. There's 1,900,000 and all zeros. So we're reading right now 1,899.8. 1899.8. 1899.8. And we're flashing to a 9 now, so it's maybe a little better, but I'll keep it at 8. We'd be good if we were at 1899.0 to 1901.0. At 1899.8, we are right in the middle and less than, well, let's see, that's, that would be thousands. So this is hundreds, so we're less than 200 ohms off of perfect. So that came out good. Let's go to the 20 megohm range. Now, same kind of problem here as I had in AC. I can get, they want us to provide 19 megohms. I can get 10, 11. I can do 11 megohms, but that's as high as the resistostat will go. So we're going to recalculate the allowable readings at this range. Let's give me a minute. Okay, we've got 11 megohms going in, and we're getting a reading of 10.999 to 11. Almost perfect, but we're going to call it 10.999. Now we would be right. Using their formula for allowable readings, this is slightly above mid-scale on the 20 megohm range, reading 11 megohms. And we would be allowable and passing the performance test if we were between 10.988 to 11.012 megohms. And we got 10.999. We're right in the middle, almost perfect. Let's see, if that's millions, then this is thousands. We're 1,000 ohms off of perfection at 10.999, and we are right on at 11. So we saw ourselves flashing, but right now we're at 10.999, pretty solid. Again, we passed the performance test for resistance, so that's the 3 tests. The unit is passing within its allowable readings, and I guess that would be the end of it. Let's see. I'm going to provide a CD manual for this unit. Be the operating and maintenance manual. It'll take you through the calibration procedures so that if you ever have to perform a calibration in the future, you can. This calibration here should hold for up to a year. So we're good. And I thank you for listening, and happy bidding.